Hello, today we will present our mini project named ServoGuard, the interactive distance-based safety system. Our member Kamin Sirisuwapong and Natthawat Inthasuwan. This project is a distance-based servo system using Arduino Uno. It detects nearby objects with an ultrasonic sensor, shows data on an LCD, and controls servo motion. User can adjust speed and set distance limit and pause or resume the system with the keypad.
About the distance concept, the servo motor continues scan in a back and forth motion. When the ultrasonic sensor detects an object closer than the preset target distance, the system triggers a warning dot, LED and buzzer. And the user can set the speed of the servo movement and the threshold distance using keypad input, granting them interactive control over the system behavior. An emergency stop function is incorporated to immediately halt all action and display a halt message, which can be a manual resume for a design concept. Okay, let's talk how it works on ServoGuard. Number 1, the ultrasonic sensor continuously measures the distance of nearby object. Press 1, 2, 3 to set a target distance. And number 2, the LCD screen displays the current distance, speed mode, and the system status, safe or danger. We can press A, B, C to adjust servo speed. We have fast mode, medium mode, and the last one is slowly. Number 3, the keypad around the user to press D to trigger an emergency stop. Number 4, the last one, if an object is too close, the red LED light up and the buzzer emits beep. The beep frequently increase as the object gets closer. Component the system require the following component. 1 Arduino, the main microcontroller board. 1 ultrasonic sensor for distance measurement and servo motor for scanning motion. Keypad for user input. LCD display for displaying distance and status. Passive buzzer for auditory warning. We use 2 LEDs, red and green, to indicate system status. Jumper wire and breadboard for connection. And the last one we use USB cable for power and data transfer.
And this is our ServoGuard. We have buzzer, ultrasonic, servo, keypad, and the LED red and green. And our ServoGuard can change the detect distance and the servo speed by using the keypad. If we press 1, it will be 10 centimeters. You can see. And it will have a buzzer dot and a LED LED. If we press 2, it will be 20 centimeters. And 3 or 30 centimeters. And the speed of the servo by pressing the letter A, B, C. If A, we press 1. If we press A, it will be fast. If we press B, it will be medium. And C will be slow. And then you can stop by pressing D. You can see. If you press again, it will appear the emergency, and you can press the asterisk to resume the ServoGuard. You can see at the person. Okay, let's go to the code. The first one is we import the required library for servo, the LCD, and a keypad. And then device initialization, the servo, the LCD, and the keypad. In keypad, we use the pin 10, 11, 12, 13, A0, A1, A2, A3. And then over here will be the pin for the ultrasonic, and this for the buzzer, for the red LED and the green LED. And over here is some the variable that we use in some function below. And in the setup, we just set up the output and input for the ultrasonic, and the output for the buzzer, and output for the red and green LED, and set up the servo in pin PB5 and the LCD when we start. And in our loop, the first one is the emergency stop. When we press the letter D, it will stop the servo. Then everything will be off. And when you press the asterisk, it will resume. And over here is the loop for the degree of the servo from 15 to 165 back and forth. So first in over here is a process keypad. So in our process keypad, we get the key, and then we check. If we press 1, the distance will be 10, 2 will be 20, and 3 will be 30. And if we press A, speed of servo will be fast, B will be medium, and then C will be slow. And if we press D, the emergency stop will be true, and then all the things will be stopped. And when we place the asterisk, everything will come back again and resume. And then in over here, I use the loop because the output is being so fast, so I need to use this loop. And then in here is the function that we update the distance and display. So in here we will show the output at the LCD. We show the distance in centimeter and the distance that the ultrasonic will detect, and the speed of the servo. So in here, if we check from the D1, the distance, if it's less than the distance D1, the green light will be off and the red light will be on. And then the LCD will print the status answer. And the buzzer will be low. And it will be late for 0.5 seconds. And if the distance is greater than D1, then the red light will be on and green light will be on. And the status will save. And the buzzer will turn off. So in here, is the last function that we use is the for calculate the ultrasonic, from the TIG pin and from the echo pin. So we calculate the duration, and we use the duration multiplied by 0.034 and divided by 2, and you get the distance in the centimeter.
Dạ ơi. Đi.
เฮ้ยแบบ